Hi all. In Module 3, we are going to focus mainly on the different methods by which the processor and the input-output devices communicate. Okay, so we have already learned in Module 1 that how a processor and different input-output devices are connected through a bus structure and how they perform different read and write operations. Okay, so in module 3 we are going to deal in detail about how these input output operations are being performed between the devices and the processor, and which is the most optimal method to perform this read or write operation. Okay, so as we all know that the most important as well as the basic feature of a computer is its ability to exchange data with other devices. Okay, and this becomes the most important part in the computer organization itself. That is how input output devices and processors communicate with each other. So in order to access input output devices, there are different mechanisms there. The most commonly known mechanism is a single bus structure. We know that there is a single bus and there is a processor, memory and different input output devices that are connected through this bus. So how does it communicate? Each of these input output devices have a unique address with them. So with this unique set of address, the processor can communicate to this input output devices. So if it is a read operation or if it is a write operation, it is using this unique address the processor will try to communicate with this input output device. Okay, so in a way this bus structure basically consists of three lines. It has got an address line, it has got a data line and a control line. Okay, address is obviously used to carry the addresses, data lines for carrying the data and control lines for checking the status flags of different input output devices. Okay, so when a processor places a particular address on this address line, any of those input devices which has that address will respond to that, and it is obvious that whatever is the instruction that is placed in that data line, that will have to be carried out by that input device which has that address which is placed in the address line. Okay, so this is how it basically works. Okay, so this is the first method which we are discussing, how processor and the input output devices communicate. Okay, so let's go back. We have already seen this instruction. This is one single instruction in which you are performing a move operation from data in register to register R0. So this is source and this is destination. You can write it either way, that is fine. I hope you remember what data in is. Data in is nothing but a buffer that is associated with the keyboard. So whatever that is being typed in the keyboard moves to this buffer data in, and from this data in it has to be transferred to the R0. Okay, or that is the register R0. Now if you want to display some information to a display device, then what you have to do is move the content of register R0 to data out. Data out is nothing but a buffer that is associated with any of the output device. Okay, so this is the first mechanism or one method by which a processor can communicate with the input output devices, that is through program instructions. You write programs through which the processor will try to read data as well as write data into the input output devices. Okay, so let's see that with an example. So before that, this is a device interface circuit. So a device has got an address decoder. Address decoder will help to decode the address that is placed in the bus. There are certain control circuits. Control circuits are used to check whether the status flag of the input output devices have been set or not set, to check that. And there are several data and status registers that helps to read the content of the data lines, whether the data that is present inside the data lines need to be written to that status registers or to that data registers. All those informations are present inside the data and status register. Okay, so this is the hardware that is required to connect an input output device to a bus. Now let's see the programming part. Now suppose we are going to perform a simple operation of displaying whatever that has been entered by a user through the keyboard, you're just echoing back to the display device. So whatever you type in a keyboard, that needs to be displayed inside the display device or a monitor. So for that, what all other things you require? So you're going to see an example of programmed input output. That is the first method. Programmed input output mechanism of data transfer between a processor and an IO device. So for that, you require 4 registers. First register is data in, then you have data out, you have status register and control registers. Okay, so data in, data out are registers that are associated with the respective input output devices, and to store the status flags you have a status register, and to store the control signals you have a control register. So SIN and SOUT, I hope you remember what SIN and SOUT are. In the first module, we have studied that you check this flag whether if it is set or not to read it from an input device. Similarly, you check if whether this flag is set or not to check whether an output device is ready to display or not. So this is the same functionality here also. KIRQ and DIRQ are nothing but keyboard interrupt and display interrupt. So these are interrupt request flags. So if they are set, that means that a display device is raising a particular interrupt. If this is set, that means that a keyboard is raising an interrupt. We'll learn that in further detail when we are learning about interrupts. For the time being, these are just interrupt request flags. Okay, and here also same, DEN is a display enable flag and KEN is a keyboard enable flag. For the time being, in this example, we are just going to look into 2 input output devices, that is a keyboard and a display device. Okay, so based upon that, we have designed these registers. This is just an example to show you how programmed input output works. So this is a program that shows you how data can be read from the keyboard and how it can be echoed back to a display device. So initializing the memory pointer, that is you are pointing to a particular location. So R0 is now pointing to a particular location, and now test bit of 0, that is you are checking whether the SIN flag, SIN flag, if it is set to 0 or not. If it is set to 0, it means that then you have to go back to the loop wait K. You're going to wait for a character to be entered. So only when the keyboard key is pressed, this bit will change to 1. That is SIN will be changed to 1 only if a key is pressed. Until then, you have to wait. Okay, that is what is meant by these 2 lines. Okay, if this bit is not 0, then it means that someone have entered a key. Then what you have to do, that entered key is present inside, or that entered data is present inside the data in register of a keyboard, that have to be now moved to the register R1 of the processor. So you're moving the content that has been entered through the keyboard to the register R1. So reading process has been done here. Now the next thing which you have to do is whatever that has been read have to be displayed or echoed to a display device, which you're going to do now. So for that, you have to check the status of SOUT. Only if SOUT status is 1, you can display, or the display device becomes ready. So testing the bit if it is 1. If that bit is equal to 0, then you have to wait until it is 1. When it is 1, you can move that content of register R1, which has the already entered data, and you can move that to data out, which is the output buffer of a display device. From this, you can move back to the display device. So once that has been done, then the continuous reading and writing process has to be carried out. The store the character and advance the pointer. That is, whatever is being entered through the keyboard need to be transferred back to the R0, and the R0 contents will be incremented as such. Now once that particular entering has to be stopped and moved to the next line, what you have to check is you have to check for a carriage return. Okay, so this is a code to check if it is a carriage return. Carriage return is nothing but to moving a printer head to the starting of a line. So if your first character is displayed and after that you want to move to the new line, okay, if you have to move to the new line, then you have to check this instruction, okay, checking if the content is an OD. OD is nothing but hexadecimal of this carriage return. So this is a default value which you have to check. You have to check if the content of register R1 is OD, then you have to move the printer head to the beginning. Okay. Now next you are going to check if the branch is not equal to 0. If branch is not equal to 0, then wait K. That is, you're continuing with the reading process. Okay. Now this particular thing is OD. That is, if it is loaded with OD character, then it means that you have to move the line field and move to a new line. Okay. So you have to move the hexadecimal value 0A to data out to indicate that your printer head have to move to a new line. So what it actually does is, each character is getting accepted from the printer and then it is moved to the display device. And once you get a carriage return, that printer head has to move to the next new line and that character need to be entered in that new line, and this process is now repeated again and again. So these number of lines has to be repeated for an input output to be performed between any input output device as well as a processor. So this mechanism is known as program controlled input output, where a single program controls the entire input output operations between the devices, IO devices and the processor. Now there are again two other methods that are described in this module. The second method is interrupts and the third method is direct memory access. In interrupts, how it is performed is that if any input output device want to perform any input or output, it will send a special signal through the bus whenever it is ready for a data transfer operation. And in direct memory access, the technique used is for high-speed input-output devices, where a huge amount of data in a lump or in a single stretch, it can be transferred between the input-output device and the memory without the involvement of the processor at all. So these are the two other methods which we'll be discussing in the coming videos. Okay, so interrupt is a mechanism in which an IO device will generate a special signal to indicate whether it is ready or not for the transfer operation. And in direct memory access, the processor doesn't have any involvement at all. Directly the input output device is accessing the memory, or directly the data transfer is done in a huge amount to the memory without the intervention of the processor.